So welcome back and welcome to Decoupling Your Architecture. What we're going to solve in this video is the problem that our reticule is not taking the value of the enum. We're going to look in detail at these ordering that things happen in, and then we're going to find a way over in our tank player controller to find the aiming component differently, and we're going to have some temporary blueprint that later will end up as C++ that solve the problem, and hopefully you'll understand why we have this race condition and what we can do about it. So before I get into the meat of this, obviously in the last video I did a boo-boo, and that boo-boo was that I did not log out the C++ begin play for the tank. So I asked you to do these logs and somehow I just glossed over this. So let me go ahead and do that now. Just going to copy the line from the constructor and just say donkey, remember our keyword, our safe word if you like, tank C++ begin play. Now let's go ahead and compile that code, just having added in these two lines to the begin play of the tank. And then we can analyze a little bit more carefully what happens from the main menu, just as a quick recap, and then we will work out why we're not getting the right color for the reticule and what the architectural issues are and learn lots of cool stuff. So if we start the game here, we get tons of stuff, including these errors, which we'll deal with in a minute, or will go away in a minute. But Donkey, if I search for that, you can see that the BP38, the AI tank's C++ constructor runs, then the blueprint constructor for that tank. So it's not that all the C++ constructors happen first. It builds object by object. It's a depth first search. Then we go ahead and get the player's constructor and the player's blueprint constructor. Then we move into the begin play regime in the same way. So let's take a look at this diagrammatically. What we have is constructors running C++ for a given object, then the blueprint for that object, then we repeat. We go around this circle until all the constructors are done. Then we move into the era of begin play, whereby the C++ constructor for a given object runs, then the blueprint, and then we repeat. But that does raise the question of how do all the objects work in the grand scheme? Okay, well that's an eyeful, but let's just focus on the left-hand side for a moment. What we do know, and you can find out for yourself if you do some extra logging, is that the aiming component will construct after the tank, because the aiming component is a component of the tank. But what we don't know is when the tank aiming component pair is going to construct compared to other things such as the UI widget and the player controller. So because we don't know what order these are going to build in, we should not care what order they're going to build in, and we should architect our code so that it doesn't matter. We just know that all of these are going to get constructed at some point. It's going to go around this loop, then this loop, then this loop, then this loop, maybe, or maybe the UI widget, then the tank, then the aiming component, then the player controller. All we know is that these two, the tank and aiming component, will happen together. Then we move into begin play, and we've got exactly the same argument. Now, before we look at the begin play, let's remind ourselves what's going wrong here at the moment. One of the things we've got going wrong is our reticule is red, our crosshair is red, even though we set aiming as the default enum here. So what it's defaulting to is enum value 0, which happens to be red, and it's ignoring the fact that in the tank aiming component's header file, we initialized the firing state enum to aiming. That's not happening. And the reason it's not happening is this to do here, check that this BP aiming component reference is set. I bet if we check that, which we can do super quickly by dragging a print node in between here, changing this firing state to a string, not even that, let's change the component reference to a string. You don't need to do this, by the way, I'm just debugging here. And pop that into the print statement. What this is going to do is that every time get aim point color and opacity is interrogated, it's going to print out to the screen the value of that pointer, and it's none. So what's happening, I'm going to undo all this stuff, is that when the player UI blueprint code reads from this BP aiming component reference variable, it's not set. And it's not set because the tank player controller has done this stuff before the tank even had an aiming component. In fact, we don't even set the aiming component in the tank anywhere yet. Remember, we used to add the aiming component as a default subobject on the constructor. We just protected a pointer, but there's nowhere do we set it. But where would we set it? That's the question. If we try and... we can't set the aiming component pointer on the tank inside the CPP constructor up here because the aiming component doesn't exist yet. We know that it's not even existent yet, so that's not going to be a good place. We don't want to be messing around doing it in Blueprint. That seems messy to me. So the next place that we could be doing it is on the tank's C++ begin play, which is here, up the top here. The problem with doing it there is we don't know that this is going to run before the player controller, and indeed, if we do it here, it may not run before the player controller. We may get the player controller begin plays and then the tank, which means that when the player controller ran and said, hey, I need a aiming component, we can't guarantee it's going to get it. So this architecture, as we have it, sucks because of these race conditions, as we call them. So now that we've identified that, let's start looking for a solution to that problem. Let's go straight into the tank player controller blueprint, and this is the first time we roll our sleeves up and actually do anything. And let's think of a different way of doing it. How about if rather than asking the controlled tank what its tank aiming component is, how about if we don't do that? How about if we say to the tank, controlled tank, find component, or let's just search for the word component, get components by class is the closest thing we seem to have here in Blueprint. So we say to the tank, okay, go get all of your components by class. Now, this is in the begin play of the blueprint, right? So we're on the right-hand side here, over here. So the aiming component will have added to the tank by now, because that happened on construction. So go find your components by class. Now, this is messy, and we're going to move this to C++ later, but for now, let's just do it here in Blueprint. If you take that array and go to Utilities, Array, and then Get, it'll automatically get item 0. And it's item 0 of that array that we can use to set the blueprint component reference. Now, the reason that's not working is because we don't have a type yet. You have to select the component class here. So you take the controlled tank, you find all components of class tank aiming component. We assume there is only one for now, which we don't have any reason for there to be more than one. So we drag from the get node back into the BP aiming component. We should get a tick this time. If you don't, for any reason, just delete this node, the get component by class node, and try again, because sometimes it gets stuck with the idea that there's no class. So what we're doing here is we're saying to the tank, okay, let's go find the component by class and set that as the variable. Why would this work any better than how we were doing it before? Because before we were relying on setting that aiming component reference in the tank. Now, I know we hadn't written any code to do that, so it's bound not to be set, but there was no sensible place we could write that code where we could be sure it'd be set at the right time. This way, it's happening on begin play. It should work okay. Let's try. The symptom will be that the reticule will be amber now. Great. So the reticule is taking the default value from the enum. If we're not sure, or we don't believe that, we could double check it by saying, okay, what's the locked state? You could go to the C++, for example, of the tank aiming component. You could set its default. You could initialize it to locked. Recompiling, which is a bit of a pain. In a bigger project, you would simply expose that as a blueprint variable and change it or something. As blueprint editable and change it, but this is going to be fine. I just want to see that the reticule is green now, and hence it's reading from the enum. It is fantastic. All right, so that is good news. We now know the order everything is working in, and we have that enum actually reading through. So what we want to do to tidy this up, of course, is to move this code that we've put in here into the C++, because we don't want to see these sort of things in our blueprint. And also, it'd be good to make this event-based. What I'd like to be saying is actually only create this blueprint widget if we found a tank aiming component. So the way we're going to do that is with a blueprint implementable event, which is going to allow us to have an event like begin play that we've created ourselves on the tank player controller, which will also have a parameter. And that parameter will get this event arrow, and the parameter will be the aiming component. And then we can only do any of this creation of the blueprint, not on begin play, but when that happens. So it's all event driven. So the tank player controller goes, okay, I found the aiming component that I need. I'm going to fire off an event, and then the blueprint is going to say, okay, let's make the UI, which is pretty cool. So let's see how to do that in the next video.